Hello, dear friends. Welcome back. So far, we have discussed various environments in LaTeX, such as tabular, itemized, etc. One of the greatest motivating forces for Donald Knuth when he began developing the original LaTeX system was to create something that allowed simple construction of mathematical formula while looking professional when printed. In this episode, we will explore mathematics in LaTeX. The fact that he succeeded was most probably why tech became so popular within typesetting mathematics is one of the LaTeX greatest strengths. It is also a large topic due to the existence of so much mathematical notation. In this episode, I will give an introduction to the world of the mathematical environment in LaTeX. So, once again, I welcome one and all to the interesting feature of LaTeX. LaTeX need to know when the text is mathematical. This is because LaTeX typesets math notation differently from normal text. Therefore, special environments have been declared for this purpose. They can be distinguished in two categories depending upon how they are presented. They are inline mode and display mode. Inline mathematic mode is used to write formulas that are part of a paragraph. Coming to display math mode, here it is used to write expressions that are not part of a paragraph and are therefore put on separate lines. So, displayed formulas are on a line by themselves in inline mode. Let us begin with inline math mode. Inline mathematical mode is achieved by using certain delimiters. We can use any of these environments or delimiters to enclose mathematical notations. First one is slash and parenthesis is there, then pair of dollar signs, and the last approach is use math environment, begin math, end math. Within that we place our mathematical notations or equations or whatever. A mathematical expression occurring in running text is produced by enclosing it between dollar signs. See this example. Let us see the output first. Two sentences are printed in different modes. Let us see the normal text first. The equation representing a straight line in the Cartesian plane is of the form ax plus by plus c is equal to 0, where a, b, c are constants. And this is a normal text. Coming to the second text, inline mathematics. Here the equations representing a straight line in the Cartesian plane is of the form ax plus by plus c is equal to 0, where a, b, c are constants. In this sentence, while displaying the equation, we can see a difference from the previous section. Correct. Here the equation is displayed in italic. Actually, it is mathematical italic. And the variables a, b, c. Again, there exists considerable space between the equal to and in the left side and right side of the equation. And coming to the variable part, it is also in italics. You can see required space between different variables. How it is achieved? So it has its own spacing rules in mathematics. Let us explore the code first. See, this is where mathematical environment is exploited. Here I am placing the equation within dollar symbol. Dollar ax plus by plus c is equal to 0. Because of this, it is appeared in a mathematical fashion. Okay, for that variables I am using separate dollar symbols. So that makes the difference, which means the dollar signs in the LaTeX is the way of distinguishing mathematical text. There are other ways also for distinguishing the mathematical text. As we have seen, we can use the mathematical equations by enclosing this particular environment, and we can also use begin math, end math constructs. See this example. The equations representing a straight line in the Cartesian plane is of the form I am beginning a mathematical environment by using the command element begin math. Within that I am included that equation. Then after that I am closing that mathematical environment using the end command. See the output, it is in italicized form. Actually this is mathematical italics. This is not our normal italics. So this is achieved by using the mathematical environment. And here I am using the slash parenthesis command. These three different approaches give you the same result. So it is up to the programmer to use different modes. There is no other differences among these. Coming to the second mode, display math mode. Use one of these constructs to typeset maths in display mode. First one is, instead of parenthesis we can use square bracket. Second option is use display math environment. For that you can enclose the equations or mathematical text within the begin display math, end display math pair. And the last option is begin equation, end equation environment. See the example. The code is self-explanatory. E equal to mc square, that is our first equation. How it is achieved? Slash square bracket E mc. I am using a cap to display. Here I am using a special symbol cap to display square. We will come to that later. Discovered in 1900 by Albert Einstein. The sentence is there. In natural units, I am using dollar sign to display the constant c. C is equal to 1. The formula expresses the identity. See, the output will be like this. And the other option, equation mode, is also used over here to display E is equal to m. I am using the equation environment. So the E equal to m statement is enclosed within the equation environment. I hope you understand this. Next important topic is subscripts and superscripts. The use of subscripts and superscripts is very common in mathematical expressions involving exponences, indexes, and in some special operations. Let us see how it is achieved. See this simple example. In mathematical mode, I am simply displaying an equation x raised to n plus y raised to n is equal to z raised to n. Let us see how it is achieved. Here I am using display mode in mathematical environment. See, for that I am using two dollar symbols. To display x raised to n, I am using cap, this symbol cap. So I am using the symbol cap in the keyboard. X raised to n plus y raised to n is equal to z raised to n. So it will be displayed like this. Some more examples are given here to see more details of superscripts and subscripts. See the output. Here a different formula. X raised to m the whole raised to n is equal to x raised to mn. So here the exponent is in different form. How it is achieved? I am using in the source part I am using inline mathematics dollar x raised to m. Within the bracket I typed x raised to m, x cap m, and after that I am using the cap command here, then n, which is equal to x raised to mn. Here I am grouping m and n because the subscript or here the superscript is more than one character long. So I am grouping using the parenthesis. We must be careful to group these characters properly. Otherwise it will give different results. See another example, it is a bit complicated. 2 raised to n. So in the exponential part we have 2 raised to n plus 1, where n is a natural number, are called Fermat numbers. Let us see how this part is displayed. Numbers of the form within the dollar sign. So which means from here to here the text should be in mathematical mode. 2 raised to, within the braces I am using 2 raised to n. So this 2 raised to n is considered as a single unit, 2 raised to n plus 1. Then you will get this result. By this way we can have superscripts of superscripts. Now let us see how subscripts are produced. See the sequence, see the statement. The sequence xn defined by x1 is equal to 1, x2 is equal to 1, x1 is equal to xn minus 1 plus xn minus 2, where n greater than 2. Here you can see this n 1, 2 and n minus 1 etc. are printed in subscript form. So this is achieved by using underscore symbol. See this code by using a pair of dollar sign. I am using x underscore n. X underscore n. See the corresponding output x underscore n. The x is in italics form because of this dollar symbol, and n is displayed as a subscript because of this underscore. And since this is a separate long equation, I am using two dollar signs, which is nothing but the display mode, and x underscore 1, which means x1 is equal to 1, slash quad symbol is there. The subscripts are produced by underscore character. Here the slash quad command is used to generate spaces between different statements. In mathematic mode, it produces thick space. We call it as thick space. So x underscore 2 is equal to 1, which means x2 is equal to 1, and x underscore n is equal to x underscore n minus 1. So here, like the previous example, I am grouping n minus 1 as a single unit. Because of that, I get x n minus 1. So here n minus 1 is displayed as a subscript. Okay, it is called Fibonacci sequence. Square roots are produced by using the command sqrt /sqrt with argument. Now let us see how these statements are displayed. Which is greater, 4th root of 5 or 5th root of 4? See the source. Here different mathematical statements are listed using the enumerate command. We have seen that. Coming to the source part, we can see two statements are displayed using the enumerate environment. Which is greater, within the dollar symbols, I am using /sqrt for 5. Here the argument 4 is optional. Okay, and the second statement is achieved by using this command. Here the optional argument is 5. See another example, 2 root 2, 2 square root 2 minus root 2. These are complicated examples. Let us see the source first. 2 square root 2. So this one is symbol. To display required space between different elements, I am using slash quad statement. Then 2 square /sqrt 2 minus /sqrt 2 will give you this particular component. Like that, other elements are displayed. See this coverage to pi. How pi is displayed here? Using the pi command. /pi will give you the pi symbol, Greek letter pi. Please also note that you can see L dot command over here. The L dot commands produces dot symbol, dot. 3 dots indicating the indefinite continuation. In mathematics, it is called ellipsis. And the single slash command here produces a thin space. Yeah, this is already explained. The slash dots command produces 3 dots. It is called ellipsis. The command slash produces thin space. One more option called thick space. It is achieved by slash semicolon. In order to display the symbol pi, we have to use command /pi. These are mathematical symbols. A list of Greek letters are given here. This is very useful while using the mathematical equations and all. See, theta is achieved by using /theta command. Like that, almost all symbols are supported in LaTeX. Binary operation symbols, relation symbols, less than, greater than, etc. Arrow symbols, left arrow, right arrow, up arrow, etc. Okay, dear friends, by that we are concluding today's session. We have to explore some more points in this mathematical environment. In the next class, we will elaborate those vital features of mathematical environment in LaTeX. Thank you.